Hello, Narnach here. Welcome to the first episode of our Let's Play for ShenZhen I. ShenZhen I is a programming puzzle game from the fine folks at Zachtronics that also brought you games such as TIS 100, SpaceChem and Infinifactory. And I have to say, I think this is their best game so far. They improved on a lot of annoying little things that the previous games had, most notably the lack of save slots. You now have an infinite amount of save slots, so you can have as many solutions as you can think up to every puzzle in the game, and you can continuously try to get better solutions to the problems and just improve and try all kinds of things without having to fuss with the save games. So, what is it? Programming puzzle. You are in this game. You play the role of a recently graduated British electrical engineer. Yes, that's not something you hear all that often. And unfortunately, you couldn't find any work back home. So you got yourself a gig in China, because of course China is where all the cheap electronics of the world are made, and also the not so cheap electronics, by the way. But we're gonna start at the bottom rung. So this is our actual desktop in the game. We are an employee. All the tasks we get come to us via email. And so, hello, welcome. Your new boss greets you. And some colleagues that are chiming in, and then important, read the manual. And most of the games you can indeed ignore the manual. This game, you don't want to ignore the manual. The manual is very, very, very useful. It's so useful, in fact, that they put a button over here that if you click it, it will open up the PDF manual in a separate window just for you. So I'll actually show you. Let's take that up. So here we have the PDF opened up. By default it opens up in Internet Explorer, so it will just work. If you have a second screen, I highly encourage you to put it up on a second screen so you can just have it next to each other. If you don't have the luxury of a secondary screen, run the game in windowed mode so it's easier to alt-tab without making it difficult for yourself. Though, so far the game has been behaving surprisingly well. Alternatively, what I actually advise you to do is to print out all 41 pages of the manual. Well, the printing instructions you don't have to print, so it's actually 40 pages. Print it out, get yourself a binder or just a neat stack, and it will make the game a lot easier for you. So, in the beginning, there's some application notes, which is just some story fluff. No, it's your immigration papers into China, things like that. It's all very nice for the story. Then there's 4 pages with language reference, which is about the assembly programming language that the game uses. If you have played TIS 100, you will really quickly get the gist of it, and you will actually value a lot of the new instructions that you get, because you're no longer fussing with really low level stuff here, you're really working on solutions. So this is really, really nice. Then we have the parts data sheet, which is the next section, which goes into all the details of all the mechanical parts or the electrical components that you will use in your solutions. And there are some interesting details in there. I'm actually just gonna scroll over there. So something about the bus systems and how data is transmitted, an example circuit, another example, then language reference, a bit of program structure. So this is just an assembly program with the instructions that the game uses. And then some conditional executions, registers, some other things, some basic instructions. So nope, doesn't do anything. Moving, jumping, sleeping, and sleeping until you get input, which is very useful. Arithmetic, adding, subtracting, multiplication, inverting value, so the not instruction, so getting specific digits out of numbers, which is rather interesting, and testing for conditions. And then after that, with plus or minus, you can manipulate things for conditional execution, also very, very useful. And after that you get a section on all the different bits, the electrical parts that come with the game. So here's the MC4000 basic microcontroller. This is the very, very first part that you get. You got a simple input here, another simple input. Well, input, output, so stuff can go in, but you can also send stuff out. This is just a continuous signal that gets applied. You got X bus, one input, one output, or again, it works both ways. And that you can use to speak with other components if you only want to send specific messages. It's like the blocking input-output from TS100, while the simple I/O is just a continuous stream that you can choose to listen to or ignore. And then the microcontrollers get larger and they get fancier bits. So, there's just lots of stuff that we'll just get. And here there's even one in Chinese, which is interesting because I don't speak Chinese, or read Chinese, which is even more relevant here. And then after that you got some supplemental data. And there's some interesting fluffy bits, for example, about a specific sound harmonizer, an algorithm here, and specific assignments will reference to specific bits. So this one is about doing something with audio. Here there's another assignment where you have to deal with values of certain ranges, but the reference of the manual is useful for specific assignments and it will always refer you to it. But the thing that I found very useful, at least in the beginning, was to just keep the language reference at hand, because you'll be flipping through this until you can dream in these instructions, and until then it's really useful. So even if you don't want to print everything, just printing a couple of these pages with the language instructions, it's gonna make your life a lot easier. So let's put that aside and let's actually get to the game. So concept mail. I'll just show you the very, very first assignment. The structure for this series is gonna be this first episode. I'm gonna show you the first couple of assignments, or the first two actually, which they're a tutorial. They are meant to show you just a basic concept. And after that, we're gonna do separate episodes for separate puzzles because, well, just like with previous games, you can tweak things just to shave off one power cycle or one production cost. And there's different solutions. So here, there are different solutions. And I'll usually take you through the first solution I got and then different steps I took to optimize it. And the nice thing is, you have multiple save slots. You can just click to get a new one. You can delete save games. You can clone a solution and you can rename them as you see fit. So I've gotten rather creative with my naming. Oftentimes just no large CPU, let's try a small CPU, then some form of insights and then even more insights. And you see for every solution, you also see here in the graph the exact score you got for that specific solution and also the best one you have gotten overall. So you can always see where you were going, and how you can optimize. But the pulse generator is actually going to be the next episode. For now, we're going to have a look at the security camera and see what this game is all about. So we have only one solution here. And this is what we start with. I think if you start this, you might start without the microcontroller in the bottom one, but in the top, they already show you a little bit of an example. So a fake surveillance camera. And if you click here on verification, you see here a very nice security camera with two lights. And they are red and they are blue. And they correspond with these two sockets. So here you see the verification information. And the expectation here is that the simple output for active is for 1, 2, 3, 4, 5, 6 time frames is gonna emit a value of 0. And then after that for 1, 2, 3, 4, 5, 6 frames, it's gonna emit a value of 100. And that's gonna go back. And this is a very even pattern. The other light for the network, it has a little bit more of an irregular pattern. So for 4 frames, it's gonna show a 0. Then for 2 frames, it's gonna show 100. So it's gonna be on. And then it's going to be off and that's going to be on, and then it repeats again. So 2 distinct patterns, 2 distinct outputs, So it's this solution is very straightforward. So here you have the very first one. This is left by your predecessor who quit the corporation or was fired. You never quite know, but they found it pretty hard. So move 0 to P0. So each of the ports on the component have a number, and in this case P0 is a simple output that is connected to the active line over here, and you can just drag in order to get yourself some connections. You can connect them and you can right click to remove them. It's rather easy, and if you hold tab you can also look underneath the components to see if you maybe spilled some soldering around. So we move 0 to P0. So what it does, it sets a null signal over here, basically turning off the light. And then SLP, which is the sleep instruction, it's gonna sleep for 6 time frames. If you're coming from TIS 100, you might be used to that every instruction advances the clock by 1 step, by 1 turn, however you want to call it. Here, the instructions are executed so fast, your microprocessors are so fast, that the instructions take virtually no time. So for all intents and purposes you can ignore that. So instead of that, you have to specifically sleep to advance to the next time interval, which is rather useful because you can do a lot of internal state manipulation, you can compare values and do all kinds of things without actually advancing the timer. So it's easier to keep multiple components in sync by just syncing up your sleep instructions. So what we do here, we sleep for 6 cycles. So what we did is we turn it off and then we sleep for 6 cycles. Okay, then after that, we are done sleeping, so we wake up again and we continue on the next line. So we move 100 into P0. So we set the value of 100 up here. And because this is a simple signal, it's just gonna stay on 100 because that's the last value we put. And it's just gonna stay until we tell it otherwise. So we're gonna sleep for another 6 cycles or 6 time units. And then we have to switch again. So after that, there's no more instructions. So as with TIS 100, when it's done executing the final line, it will loop back and start all the way back at the top again. In that case, it's gonna move 0 back to P0. So here, last we left off, it set a value of 100 on the line. Because we now loop back, we set it back to 0, we reset the value and the light goes off. So this is very, very straightforward. The line that we have to implement ourselves is slightly more tricky because the pattern is more complex, but we can apply the same principles. So again, the output is connected to P0, so that's very easy. So we start by setting it to 0 and we sleep for 4 seconds, for 4 time intervals, seconds. I'm just gonna call them seconds. Let's keep it with seconds for now. So we sleep for 4, then we wake up again. We turn on the light by sending the value of 100 back out through the port. And then we sleep for 2 seconds. Then we wake up again, we reset the value because we have to turn it off. And we turn it on by doing another 100 and then we sleep again. And after that we loop back because the pattern is done here and we repeat. And then if we go through it step by step, still sleeping. Here you see the time slowly advancing. Because we're in the middle of a sleep and if all the components are sleeping, nothing happens. Okay, so now we are done sleeping here. And here you can see that the next instruction is going to move 100 into P0. So once we do a step, you now see this one is glowing. It's a value of 100 that has been emitted. And here you see that the light is indeed on. The blue light is now on. So once we step further, this one goes back to a sleeping state and we're gonna sleep for 2 seconds. This one is still sleeping, so that one just continues. Time advances. And both of the components are gonna do something different. They both stop sleeping. So this is now gonna move 100 in here to turn the light on. This is gonna move 0 in here to turn the light off. So we do that, then you flip, and indeed, red light is on, blue light is off. And then, oh, this one is still executing. This is about to execute something. Now we step, and then they actually execute the sleep. And this one is in a sleeping state. The sleeping state is also useful because while sleeping, it doesn't consume power. Your machine doesn't consume power. And one of the ways that your score is graded is by how little power you use. The other way that things are graded is by how expensive your components are. And that is what you can see here. This one costs 3 yen, 3 yen, 5 yen, 1 yen, 0 yen. So, for example, this one, oh, we're in the middle, but this one is larger, so you can also fit more instructions in, you can connect more components to it. It has all kinds of interesting side effects. So you might want to use it, but well, the trade-off is going to be that it's more expensive. So different solutions will lean towards different directions. But we're going to advance through it one entire time unit at a time. And as you see, the lights keep changing color and the instructions keep changing. And if we just hit simulate, it's just going to advance the time and the lights are going to keep blinking. And here you see for every stage the power usage that we had. And it's just going to cycle through and it will keep some familiar things. Later on, once you also get inputs that you will act upon, you will also get different input patterns as with the previous games with TIS 100, where if you might build a solution that works for the specific sample that you are shown, but then after that you get other samples that might disqualify it. So you are always encouraged to build a solution that solves the actual problem rather than fitting something that specifically only works for a specific subset of the input. Now that we are done, we get our score screen and I haven't changed the code, so our now and was are still the same. If you made changes to the code, then you will actually see a before and after what it was in terms of cost. But this is a really, really simple one, so there's not a lot of solutions. And then we can go back to the email. Okay, and if this is the first time that you solve something, then oftentimes you get a nice email from your boss thanking you for your hard work. And then oftentimes 1 or 2 emails will pop back in. Maybe some extra bits like, for example, hey, we got a new part, you can use it now. And the interesting bit is that parts you unlock in later assignments, you can go back to earlier assignments and actually solve those assignments in different ways using the new components. So sometimes, in order to optimize something, you might need quote-unquote future parts in order to optimize it further. Okay, let's look at the second sample or tutorial mission. So here we have an input and we have an output. So control in is a simple input connected to some factory equipment. Control out is a simple output connected to some other factory equipment. And I think we're building a signal booster here. So the signal from control in should be multiplied by 2 and copied to control out. So my first instinct here was to solve it in the TIS 100 way. So you move the value from P0, the input, to the accumulator, which is an internal storage buffer. It's a register, technically. So this can hold one value. Later on you get the expensive one, which actually has 2 registers, an ACK and a DAT, to store values in. But here, ACK is what you can work with. So we take a value, we store it internally. Now we add the value that's in here, add it to itself, and we store the result back in accumulator. So if you have something and you add something to itself, basically you're doubling it. So that was my first instinct, having a little bit of a background in TIS 100, not realizing there's a multiplication instruction, which we will use later on. But this doubles the value, then we move the value from the accumulator to P1, which is the output, and then we sleep for 1 second to wait for a new input. So here we get a value of 25 in, and the expected output is 50. So what if we do? Take a step, the value of 25 is put on the input, then we step through, we added it to the accumulator. Next up, we're going to add the accumulator and store the value, add the value to itself and store it back, so it's going to be 50. And we send it out, and we sleep for a second to allow the other equipment time to read it, and we wait for a new value. Now we get 0. So 0 times 0 becomes 0. We move it out and we sleep. And if we simulate it, it works exactly as specified. But the goal of this specific puzzle is of course to show you that there's input and there's output. So the first two puzzles, assignments are really simple and really meant to show you the ropes. After that, it gets more interesting. So next up, please enjoy a game. It's kind of interesting, funny thing. So the boss's daughter's learning programming and built a game that he wants you to try. So you really have to go back to your desktop and play a game of solitaire. And then once you have finished this, it completes and you can continue. So there's little whimsical things in there. And actually, it was kind of fun. I haven't played solitaire in quite a long time. So it was fun as a nice little diversion. And after that, we get a new part. And there's just some random story bits coming through. And then we get to the first true assignment. The difficulty of the assignments in this game, I think it ramps up a bit quicker than in TIS 100. But it's fun nonetheless, and especially because you just have this really nice way to manage your save games or your solutions. It works because you really can just iterate on the solutions. But as I said, the pulse generator, we're going to do it the next time as our very, very first true assignment. So I hope you enjoyed this little introduction to the game. It might be just too much intro, might be a bit too please show me the real puzzles, but yeah, that's gonna be next episode. So thank you for watching. I'll see you again next time. Bye bye.